Welcome to this explainer. Let's get right into it. Right now, everyone's completely obsessed with the AI boom. But what if we're all looking at it totally backwards? What if the market is pricing this as a pure software revolution, when in reality it's a massive, capital-intensive, heavy industrial infrastructure build-out? Let's dive in because the source material we're unpacking today is going to completely flip how you think about AI economics. Here's our roadmap for today. We're going to quickly cover the AI software illusion, the law of stack gravity, history's repeating infrastructure cycles, physical compute constraints, and finally, redefining capital allocation.
All right, part one, the AI software illusion.
People look at AI and expect classic software dynamics, right? They expect exponential growth, assuming open source development will just compress capability gaps, and that enterprise switching costs will stay pretty low. But that illusion is hitting a brick wall of physical reality. We aren't just dealing with code here. We're dealing with multi-year lead times for physical parts, insane capital requirements, and literally needing sovereign government approval just to plug into the power grid.
So, it really forces a massive question. If performance differentials between leading models are narrowing, and the moat isn't actually in the AI models themselves anymore, where's the structural advantage accumulating? Where's the real leverage?
Which brings us to part two, the law of stack gravity.
Stack gravity is a brilliant concept from the research. It's basically this recurring tendency for economic value and strategic leverage to pool at whichever layer of a tech stack represents the binding physical constraint. It's a foundational rule. Value doesn't just pool where the hype is, it flows directly to the hardest physical bottleneck. Check out this machine economy stack. Up at layer 4, you've got logic and orchestration. That's where the models live. But the structural conditions for durable pricing power up there are actually weakening. The real scarcity is migrating down to layer 2, energy and compute. Physical compute infrastructure, not model intelligence, has become the industry's true binding constraint. You can engineer the most elegant algorithm in the world, but you absolutely cannot out-engineer a lack of electricity. There's a quote from the source material that hits the nail on the head. Applications attract attention. Infrastructure captures economics. We saw the exact same thing with cloud computing. AWS didn't become a high-margin behemoth because of its apps. They won because they recognized that the infrastructure layer is where durable economics sit. Let's look at part 3, history's infrastructure cycles. This migration of value is a repeating macro pattern. In the 1870s, the economic winners were the ones controlling the physically constrained railroad tracks, not the freight businesses running on top of them. In 1890, it was the electricity grid operators. In the 90s, TSMC dominated not just by designing chips, but by controlling fabrication capacity right alongside the boom in physical telecom. And in 2006, AWS grabbed the cloud layer. The pattern literally never breaks. Whoever controls the constrained physical network accumulates the structural power.
But here's the catch. These cycles are not linear. They almost always end in massive overcapacity. Think of the 1990s telecom bust or the bankrupt railroads. The strategic opportunity isn't about betting on permanent scarcity. The massive leverage is found by positioning yourself correctly during this early constrained build-out phase, long before that commodity infrastructure bubble inevitably pops. And that is exactly where we are with AI right now.
So, what are these bottlenecks? What exactly are the binding physical constraints choking the AI build-out today?
Let's move to part 4, physical compute constraints.
These are the harsh, tangible realities. We are talking strictly constrained power procurement. Advanced GPU allocation at the training cluster scale is severely limited. Simply finding a plot of land with a viable grid connection and the right political approvals is incredibly rare. And get this, you could be waiting literally years just for a high-voltage transformer to be delivered. You can't solve these problems with smarter code. They only yield to massive capital, time, and political alignment.
It creates this crazy domino effect. The AI build-out propagates way beyond just GPU demand. It flows down into networking, then into massive power infrastructure, advanced cooling technologies, and ultimately it slams right into sovereign utility grids. This isn't a narrow software cycle, it's a highly coordinated industrial capex cycle.
Just look at the frontier AI labs. The capital required for competitive compute now exceeds what independent labs can efficiently self-fund. That's incredibly revealing. We're seeing labs that pride themselves on safety and independence having to partner up to access compute from facilities linked to direct competitors. The Colossus facility in Memphis is a perfect example. It's signaling that it's an external compute platform now, not just an internal asset. Even the most well-funded labs are realizing they have to compromise their independence to access scarce infrastructure.
And we can't ignore the geopolitical level. Governments are now treating compute capacity the exact same way previous generations treated ports or oil reserves. We've got US export controls and sovereign AI initiatives popping up in the Gulf, India, Japan, and Europe. Energy nationalism is literally dictating where infrastructure gets built, leading to a regional fragmentation of the global compute market. Compute is pure national strategy now.
If the rules of the game have completely shifted from algorithms to heavy infrastructure, how must our financial mental models adapt to a reality defined by steel, power lines, and sovereign borders? Finally, Part 5, Redefining Capital Allocation. If you try to apply software valuation metrics to an infrastructure build-out, you're making a fundamental analytical error. In a pure software market, your moat is algorithmic differentiation, your constraint is developer talent, and you value companies based on terminal value and high multiples. But in an infra build-out, your moat is physical scarcity. Your constraints are power, land, and literal transformers, so your valuation has to shift toward long-duration project finance. Valuing Layer 2 compute constraints with Layer 4 software multiples is a recipe for a really bad map. I want to read this quote from the conclusion of our source material, because it perfectly anchors the central thesis of our entire explainer today. The market may still be pricing AI primarily as a software revolution. It may increasingly behave like an infrastructure build-out.
Stack gravity isn't just a clever metaphor. It is the physical reality dragging the economics of the AI industry down into the hardware, the grids, and the steel. So I'll leave you with this to think about. As you map out the future of this space, are you preparing for a fleeting software cycle, or are you positioned for the heavy physical reality of stack gravity?